This video is for you who are starting to study English or improving your pronunciation, or even for those who are adapting your ears to the language. The audio with the text will help you in your studies. While you get familiar with the English language, you learn content for your life. This video can be very useful for aviation personnel, with the presence of technical terms used in aviation. Today, we're going to talk about cabin depressurization. This is a matter of extreme importance in aviation, as occurrences like this can cause serious problems for everyone on board and can even lead to an aviation accident. We hope you enjoy the video. We will present the subject, bringing some causes and possible consequences. Watch until the end and make the most of your studies. Cabin depressurization is the sudden reduction of air pressure inside an aircraft. This event can occur for a variety of reasons, such as malfunction of the cabin pressure control system, structural damage to the aircraft, and others. When a depressurization event occurs, oxygen levels in the cabin drop rapidly. In the event of cabin depressurization, it is important to follow the instructions of the cabin crew and immediately put on the oxygen mask. The mask will provide the oxygen needed for passengers and crew to breathe safely until the aircraft can descend to a safer altitude. Cabin depressurization poses a serious risk to the safety of passengers and crew. It is important to be aware of the risks associated with this condition and to know what to do in the event of cabin depressurization. Causes: human errors. During the operation of the cabin pressurization system, human errors can lead to depressurization. Doors that are poorly sealed, improperly sealed, or possible failures in setting the correct cabin pressure levels can allow air to escape from the aircraft. Incorrect handling of the pressurization controls can also cause depressurization if the flight crew is not familiar with the system or does not take appropriate measures to prevent leaks. To reduce the risk of depressurization caused by human error, the flight crew must receive adequate training on the cabin pressurization system and must be instructed to follow all standard operating procedures. Mechanical failure. Mechanical defects in the aircraft's pressurization system can cause depressurization. A malfunction of sensors or a valve in the pressurization system, such as the safety valve or outflow, can cause air to escape from the cabin, causing a gradual or sudden decrease in pressure. To reduce the risk of depressurization caused by mechanical defects, aircraft must be regularly inspected and maintained in operational condition. Structural failures. Adverse events, such as severe turbulence, cracks or chips in windshields, bird strikes, or other external factors that cause damage to the aircraft structure can be precursors to depressurization. In the event of a possible structural failure, such as a sudden opening in the fuselage, aircraft windows, or emergency exits, it can result in a rapid release of pressurized air from inside the aircraft. Maintaining the structural integrity of the aircraft is crucial to preventing the risks associated with depressurization incidents, ensuring the safety and well-being of both passengers and crew. Regular inspections, preventive maintenance, and adherence to rigorous safety measures are imperative to address and mitigate potential structural vulnerabilities in aviation. Cabin pressure control system. Complications in the aircraft systems responsible for maintaining cabin pressure can result in a sudden depressurization. These systems are responsible for keeping cabin pressure at safe levels, and when failures occur, pressure can drop rapidly, causing depressurization. Until now, we have talked about concepts and verified how important the theme depressurization is for aviation. We were able to list and learn about 4 possible causes that can lead to a depressurization of an aircraft. Human error, mechanical failure, structural failures, and cabin pressure control system. Now, let's continue our studies and learn a little more. We will talk next about some possible consequences of a depressurization of an aircraft. Consequences. Compromised structural integrity. The fuselage is the external structure of an aircraft that houses the cabin, wings, and landing gear. It is typically made of aluminum or carbon fiber composites. Abrupt changes in pressure can cause damage to the fuselage in a number of ways. Compression forces can cause cracks or bends in the structure, while shear forces can cause ruptures. Advanced pressure monitoring systems can help detect abrupt changes in pressure before they cause damage. These systems typically use sensors to measure the internal and external pressure of the aircraft. More resilient materials, such as carbon fiber composites, can help reduce the risk of structural damage caused by abrupt changes in pressure. Regular aircraft maintenance is also important to ensure structural integrity. This includes visual and non-destructive inspections to identify any potential damage. Reduced oxygen levels. Cabin depressurization can lead to hypoxia, a condition in which the body does not receive enough oxygen. Hypoxia can cause symptoms such as shortness of breath, rapid breathing, increased heart rate, and mental confusion. In severe cases, hypoxia can lead to unconsciousness or even death. Hypoxia can occur in different degrees, depending on the severity of the depressurization. In mild cases, symptoms may be mild and transient, such as dizziness and difficulty concentrating. In severe cases, symptoms may be more severe and even fatal, including seizures, coma, and death. Cabin depressurization is a relatively rare event. However, it is important to be aware of the risks associated with this condition, so that passengers and crew know what to do in an emergency. In the event of cabin depressurization, it is important to follow the instructions of the flight crew and put on the oxygen mask immediately. The mask will provide the oxygen needed for passengers and crew to breathe safely until the aircraft can descend to a safer altitude. Decompression sickness. Decompression sickness, also known as the bends, is a condition that occurs when the air dissolved in the blood and tissues expands and forms bubbles after a rapid decompression. These bubbles can cause severe pain, dizziness, and other symptoms, which can be fatal in severe cases. Decompression sickness is more common in divers, as they are exposed to high levels of pressure. However, decompression sickness can also occur in people who travel by plane, climb mountains, or work in pressurized environments. Decompression sickness is a rare condition in aviation. However, it is important to be aware of the risks associated with this condition and take the necessary steps to reduce the risk. Decompression sickness is classified into two types, Type 1 and Type 2. Type 1 is the most common type and is usually characterized by pain in the joints and muscles. Type 2 is the more serious type and can cause damage to internal organs, including the brain, heart, and lungs. Compromised stability and performance of the aircraft. When the internal pressure of an aircraft decreases, there can be serious consequences for the safety and performance of the aircraft. In addition to the health risks to occupants, the aircraft's flight dynamics can be affected. Depressurization can interfere by altering the balance and aerodynamics of the aircraft, which can impact the aircraft's maneuverability and pilot control. These changes may require immediate adjustments to the way the aircraft is flown to maintain a safe and stable flight. If depressurization is caused by structural damage, such as a crack in the fuselage, it can further compromise the aircraft's performance, making it even more difficult to maintain the desired trajectory and altitude. Great that we made it this far together. In the first part of the video, we discussed possible causes that can lead to depressurization of an aircraft. In the second part, we covered possible consequences. Let's review. Causes: human error, mechanical failure, structural failures, and pressure control system. Consequences: compromised structural integrity, reduced oxygen levels, decompression sickness, and compromise stability and performance of the aircraft. I hope you enjoyed it. You can watch it as many times as you want. You can pause it, and even go back to any point where you were unsure. Don't forget to write down new words and continue your studies. Stay tuned, as we will bring new videos like this. We would be happy to hear your opinion. Write a comment. Thank you for staying with us until here. Until next time, bye.